The graph of the function f is given. We want to use the graph to estimate the following. Part A, all the local maximum and minimum values of the function and the value of x at which each occurs. And then B, the intervals on which the function is increasing and on which the function is decreasing. And then enter your answers using interval notation. So we can see here that we are starting on the left hand of this graph from negative infinity. So it's going from negative infinity, and you can see here, because there's no closed dot, you want to assume that there's an arrow there going towards negative infinity. And over here on the right hand side, it's going towards positive infinity on both ends. Okay, so what's going to happen is we still need to first know what are the points on the graph that we can label. We can see that on the y-axis, it's going in increments of 2. So it's going from 0 to 2, so that means that this is going from 0 to negative 2. And then it's going to go 2 to 4, and it's just 2 to negative 4. And then 4 to 6 here, and negative 4 to negative 6. And then that's going to go to 8. Okay, and then on the x-axis, it's going in increments of 3. So we go from 0 to 3, 3 to 6, 6 to 9, and then 9 to 12. And so on. And then on the left side of the x-axis, this is going from 0 to negative 3, and then negative 6, negative 9, negative 12. Okay? So now that we know what those points are, now we want to figure out, okay, where's a local maximum and local minimum? Well, the maximum is where it peaks in the graph. So if we start here, okay, we're looking at the turning points. If we start on the left-hand side of the graph and then scroll all the way down here, well, this is a turning point. And that turning point is at the ordered pair negative 9, negative 4. And then it's going to increase to the top here, and it's going to end up peaking at this value. And so therefore, there is another turning point at 0, 8. And then we're going to go down here, and then there's another turning point at 6, 2. Okay? So what we want to do is we want to figure out, okay, which represents the local maximum. The local maximum is, okay, now the maximum goes all the way to positive infinity because the arrow tells us that. So that is the absolute maximum. The local maximum is the highest that it peaks in the peak and valley of the graph. So you can see here that it goes to the value of 0, 8. So we can see that the local maximum, there is 1, and that local maximum goes from 0 to 8. And since there are already parentheses around here, we don't need to put the parentheses in the particular problem there. Okay, now we need to find the local minimums. So there are more than one local minimums. We can see here that there's a negative 9, negative 4, and then here's another local minimum, which is 6, 2. Now, the smaller of the two is the lower that the actual graph goes. And so here it's negative 9, negative 4, and then the other one's going to be 6, and then 2. Now the intervals on which the function is increasing, we want to find that. So here we can see that it starts here at the left at the value on the x-axis of negative 9 all the way to 0. So we know that it's increasing from negative 9 to 0. And then it's also increasing starting at the turning point of 6 and going towards positive infinity. So we know it's increasing from 6 to infinity. Okay, now where is it decreasing? Well, over on the left-hand side, it's decreasing from negative infinity all the way to negative 9. So it's starting at negative infinity to negative 9. And then it's also decreasing from 0 to 6.